So for which values of x this series is convergent? Remind yourselves of geometric series with general form of a r to power n minus 1 and start from 1 goes to infinity, but this is just general pattern. As long as you can fit your series into this form, then you have a geometric series. Remember the ratio. For the ratio r, if the absolute value of r is less than 1 or r is bounded between -1 and 1, this guy is convergent to a divided by 1 minus r. So let's see if we can rewrite this series in the format that is similar to geometric series. Rewrite your series as the summation of sine x divided by 3 to power n starts from 0, goes to infinity. This is basically the summation of r to power n. So you have your ratio. Ratio is equal to r. Absolute value of r is equal to the absolute value of sine x divided by 3, and it must be less than 1, so you get a convergent series. Let's do a little bit of algebra, everyone. So far, we know that the absolute value of sine x divided by 3 is less than 1. Multiply both sides by 3 to get rid of your denominator. You end up with absolute value of sine x less than 3, or sine x is bounded between -3 and 3. Well, as long as your x can satisfy this relation, then you are done, all right? You can take arc of both sides, left side, right side. You have to take the arc of the middle side as well. So as long as your x is bounded between arc sine of 3 and arc sine of -3, then you are done. So either is fine. If you don't feel comfortable about writing arc sine, because you have to use a calculator to calculate the values for your inverse sine or arc sine. Another way to write this guy down is inverse sine of 3 and inverse sine of -3. So as long as your sine x is bounded between -3 and 3, or your x is bounded between arc sine of -3 and arc sine of 3, then this series is convergent. So this is what you're going to write. As long as sine x is bounded -3 and 3, or x is bounded between inverse sine of -3, inverse sine of 3, the series of sine x divided by 3 to power n and start from 0 goes to infinity is convergent to a divided by 1 minus r. But a in this case is equal to 1. R is sine x divided by 3. So this guy is equal to 1 divided by 1 minus sine x divided by 3, which can be written as 3 divided by 3 minus sine x. Or another word, as long as sine x is bounded between -3 and 3, then the series summation of sine x divided by 3 to power n and start from 0 to infinity approximate the function 3 divided by 3 minus sine x. So this is the takeaway from finding a divided by 1 minus r. Approximate function. Then we take a look at Desmos. To actually visualize what's going on here. Okay, let's take a look at Desmos together. Let's erase previous functions. So here we have 3 divided by 3 minus sine x. And then take a look at this quantity that you have. One plus sine x divided by 3 plus sine x divided by 3 to the second power plus sine x divided by 3 to the third power, and you continue this process, right? We have a good approximation for this rational function. This is 3 divided by 3 minus sine x, and this is what you have here. Later on, when we're introducing power series, Taylor series, Maclaurin series, we can see how we can approximate sine function itself using some polynomials.